This is a review video for Unit 7, Sections 5.1 through 5.4. For number 1, we use this Pythagorean identity, so we can replace this with the square root of cosecant squared x, which gets rid of the 2, and then this is just, well, the answer, because they said one of the 6 trig functions. You don't necessarily have to write it as 1 over sine x. Next up, there's a common factor, so if we pull that out, we have cotangent of x times secant squared x minus 1, and this is a trig identity. This right here can be replaced with tangent squared x. So cotangent x times tangent squared x, well, think of this as 1 over tangent multiplied by tangent squared x. So this goes away, the 2 goes away, and our answer is tangent x. The bottom of this fraction, using the Pythagorean identity, can be replaced with sine squared theta. So instead of taking it as tangent divided by sine, we can think of it as tangent theta times 1 over sine squared theta. And the reason we do that is because that way when we replace tangent with sine over cos, it's easier to multiply. So one of the sines cancels out, and then we have 1 over cosine theta sine theta. If I was going to rewrite that, I could write it as the secant of theta times the cosecant of theta. So this one has a common factor that we can pull out. We can say that tangent squared times cosecant squared minus 1. From here, there's an identity. We can replace cosecant squared minus 1 with cotangent squared. So if we do that, we have tangent squared times cotangent squared, which is just going to give you 1. Trig identity here on the left, this becomes sine squared x. With cosecant, we flip it, so it's 1 over sine x. So the sine goes away and the 2 goes away, and the answer is sine x. Our usual strategy, anything that's not sine or cos, we change to make it sine or cos. So if we replace tangent with sine over cos and secant with 1 over cos, we have this. Notice what's on the bottom of every single fraction. What if I take the entire thing and multiply it by cosine of x? What that gives me is cosine squared x plus sine squared x is equal to 1. Well, that's just true, because on the left, that's the Pythagorean identity, so we get 1 is equal to 1. Verified. Here we're going to replace sine squared x with 1 minus cosine squared x from the trig identity. So we have cosine squared x minus 1 minus cosine squared x is equal to everything on the right. And what happens here is that we can add these because the negative is distributed, so it ends up being 2 cosine squared x minus 1 is equal to whatever's on the right, which is 2 cosine squared x minus 1. Look at that, we're done. Again, anything that's not sine or cos, we change so that it's written in terms of sine or cos. So this first part gets rewritten as 1 over cosine x minus cosine x is equal to sine x times sine x over cosine x. Notice the common denominator. So what if I take this whole thing times cosine x? That gets rid of all my fractions. And everything works out pretty nice here. On this side, the cosine cancels out, and we have sine squared x. So notice what happens here. I could just look at the trig identity. Sine squared x is equal to sine squared x. So while I could treat this as switching everything to sine and cosine, remember that this is just cotangent of x, and this is just going to be 1 over, so you flip it. So it becomes tangent of x, and we are actually just done right there, if you remember those reciprocal relationships for tangent and cotangent, even when they're on the bottom. So let's solve this like it was a quadratic, where we add 4 to both sides, and then we divide by 3. So we have, well, let me just write it out. 3 secant squared x is equal to 4. So, secant squared x is equal to 4/3. And then we take the square root of both sides, so we have the secant of x is equal to plus or minus the square root of all of that, which let's just simplify. Let's call it 2 over root 3. Now, why am I leaving that as root 3? Because it's irrational, and 4 simplifies nicely to 2. And we can actually look on the unit circle and figure out where this shows up. So first, I guess let's flip this. If this is secant x, well then what about cosine x? That's going to be root 3 over 2, and plus or minus. So if you look at your unit circle, where is this going to show up? It's going to show up here at 30 degrees. That's where we're going to have root 3 over 2. And it's also going to show up here at negative 30 or 330 degrees, which means there's the similar relationship on the other side. After all, this whole thing's symmetrical. So we'll be here at 150 and 210 degrees. If you want to think of it in terms of radians, you absolutely could. I'm just showing you in degrees. So those are the 4 places where this is true, where secant x is plus or minus 2 over root 3. How can we write that in a concise way? Well, if you look at 30 and then you add 180, you get to 210. And the same thing is true if you look at 150 and you add 180, you get to 330. So those are my 2 unique answers. You could write it as 30 degrees plus 180n, and then 150 degrees plus 180n. If you wrote the same thing in radians instead, it would end up being pi over 6 plus pi n, or 5 pi over 6 plus pi n. Oh, just an observation, only on this interval. So actually, those are just your only 4 answers. You're done. You don't have to solve it forever. So ignore the plus n stuff, just those 4 answers. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Next up, let's do plus 1 and then divided by 3. So we have cotangent squared x is equal to 1/3. If I square root that, I have cotangent of x is equal to plus or minus the square root of 1/3, which let's just write it as 1 over root 3. I think that'll work. So if we wanted to, we can flip this and say the tangent x is plus or minus root 3. And if you're not sure where that shows up on the unit circle, you could always take the tangent inverse of the square root of 3, and it will spit out your answers. And since we are solving within this interval only, you can also do the other one, which is negative root 3. And this will tell you where your 2 answers are. You still have to write them on the quiz. I'm just showing you the work. For this one, the 3 stays inside because that's more of a horizontal shrink than anything else. So we're just going to take the square root first, and this tells us that tan of 3x is equal to root 3. And that's plus or minus root 3, excuse me. So that would mean that our typical answer is very similar to the last one. Was going to be pi over 3, that's what the first one would be, and plus pi n, that's the period of the tangent graph. And then the other one would be 2 pi over 3 plus pi n. But all of this is equal to not just x, but 3x. So if I want to solve for an actual x, I have to shift things over, and this becomes pi over 9 plus pi over 3n. And this becomes 2 pi over 9 plus pi over 3n. So I'll put a semicolon there to indicate that there are 2 solutions to this one. Remember that there's the positive and the negative solution. So for this one, we can probably start directly looking for where on the unit circle do we see root 2 over 2. And if you look, that's going to show up here at 45 degrees and here at negative 45 or 315 degrees. The equivalents are pi over 4 and 7 pi over 4. So since it's cosine, the period there is going to be 2 pi. So I can think of my answer. I can write x over 2, because that's what cosine is. That's the horizontal stretch this time, is equal to pi over 4. That's the first answer there at 45 degrees, plus 2 pi n. And then my second answer, 7 pi over 4 plus 2 pi n. And how do I solve for x? I double these. So I double the entire thing. And that means that x is equal to pi over 2 plus 4 pi n, 7 pi over 2 plus 4 pi n. So what you can see from here is that this one, having a whole number, is a horizontal shrink. And this one, having a fraction, is a horizontal stretch. So for this one, pi over 4, that's the equivalent of like 45 degrees. And pi over 3 is the equivalent of 60 degrees. What we're actually trying to do is figuring out what the cosine of 105 would be. You could get a crazy irrational decimal using your calculator, but if you want to find the exact answer, you have to break it into the component parts that show up on the unit circle. And then we use this difference of sums formula, which tells us that the cosine of 45 times the cosine of 60 minus the sine of 45 times the sine of 60 is equal to the cosine of 45 plus 60. So we can solve these for their exact value, which comes in radicals. And let's use those parentheses just so we can avoid some mistakes there. This is 1/2. This is root 2 over 2. And this is root 3 over 2. So if you multiply these things, they're all going to end up over 4. On the left, we have root 2 over 4 minus, and on the right, we have root 6. And there's your answer. If you took the cosine of 105 in your calculator, whatever you get would be equal to this. But this is the non-decimal version. So with this one, this radian is like an angle in a way. And if we want to figure out where we're at in the unit circle, you can take this times 180 over pi, which cancels this out. And we find out that we're at negative 105 degrees. So if you think about on the circle, where that is, we would be somewhere over here. But there's no exact values there. So how can we split 105 into relevant parts? Well, what if we did it as negative 45 plus negative 60? Because those actually have exact values, and they'll bring us to that place as long as we use this relevant shortcut. So they want you to do all three, which is kind of exhausting, but let's go for it. Try to clear a little bit of room here. And just remember that I switched this to degrees, and I split it like this. So that's the sine of, here's the sine one. And if you replace that, you get all of this. So if you simplify that, you'll get negative root 2 minus root 6 all over 4. For a cosine, we do the same thing. We do negative 45 plus negative 60, and we use that different formula there. And this gives us root 2 over 2 times 1/2 minus negative root 2 over 2 times negative root 3 over 2. So if I simplify that for cosine, I get root 2 minus root 6 all over 4. Remember that tangent is equal to sine over cos. So if I think about that as sine divided by cos, I can take my sine, which is this, and multiply by the reciprocal, which is this. The 4's go away, and my tangent answer is negative root 2 minus root 6 all over root 2 minus root 6. And none of those cancel out. Here we're working backwards. We're using the cosine of pi over 7 plus pi over 5 formula. And if we simplify that, we get cosine of 12 over 35 pi. You just have to make the denominators the same so that you can add them. So here you start with tan u is equal to 3/4, and cosine v is equal to negative 4/5. You can absolutely draw some triangles and figure things out from there. They tell us which quadrant we're in for each one. Since u is in quadrant 1, both of these will be positive, your cosine and your sine. And since v is in quadrant 3, both of these will be negative, your cosine and your sine. So if you take the sine of the tangent inverse, you can find sine of u. It's going to be 3/5. And cosine of u, it's going to be 4 over 5. Because we're in quadrant 1, everything is positive. To find sine of v, we're going to take the sine of the cosine inverse of negative 4 over 5. And whatever we get as an answer, we know that it's going to be negative. So even though you might get 3/5, it's going to be a negative 3/5. And we know from above, since they gave it to us, that cosine v is negative 4/5. Now we have enough information to plug this in. So let's start with the shortcut we know, which is sine of u minus v. And we can plug all these things in. So we're looking at sine u cosine v minus sine v cosine u. And if you plug those in, that's 3/5 times negative 4/5 minus negative 3/5 times 4/5. This gives us negative 12 over 25 minus a negative 12 over 25, or 0. But that's what sine was. If we want to figure out what cosecant is, we flip it over. We have 1 over 0, and our answer is undefined. All right, in section 5.5, the first thing we're going to look at is this here to determine which quadrant we are in. So if you think about starting at 0, right over here is pi, and right over here is 3 pi over 2. So if you were to go like that or that. So that means we are in this quadrant, quadrant 3, which means that our sine and cosine are both going to be negative. So let's keep that in mind. Quadrant 3. And if we have a cotangent of u is equal to 2, we can think of that as the tangent of u is equal to 1/2. So if we think about what our triangle might look like, we're somewhere down here, and our opposite is going to be 1, our adjacent is going to be 2, and then we have our hypotenuse. That's where we're going to get the square root of 2 squared plus 1 squared, or the square root of 5. If triangle doesn't make sense to you, there's always the other shortcut, where if you want to figure out what the other values are, you can take the sine of the tangent inverse of 1/2, and then you can take the cosine of the tangent inverse of 1/2 on the calculator, these nice little shortcuts. And if you do that, you'll get negative 1 over root 5, and for this one you'll get negative 2 over root 5. Now you might actually just get 1 over root 5 and 2 over root 5, but because we're in quadrant 3, everything's negative, both sine and cos. So these we can now plug in. So let's recap what we have so far. Sine u is negative 1 over root 5, and cosine u is negative 2 over root 5, and the tangent u is 1 over 2. So we're going to use these different double angle formulas. So for sine of 2u, that's going to be equal to 2 times negative 1 over root 5 times negative 2 over root 5. That's just replacing sine and cosine with what they're equal to, which is just going to give us 4/5. So that's what we'll write over here, 4/5. For the cosine 2u formula, we're going to use this one and plug in whatever cosine is equal to. So if we simplify that a little bit, we're going to get 3/5, which goes right here. Now this one was a typo. That should have been the tangent of 2u. I don't know if I fixed it in your version or not. And think about 4 over 5 over 3 over 5, because tangent is sine over cos. And those cancel out, and we have 4 over 3. An alternate version of that would be 4 over 5 times the reciprocal, where they cancel out. Two different visuals for the same thing. Here's the next one. This is going to be the square root of 4 squared plus 1 squared, or the square root of 17. And the cosecant is like the sine, but then it's flipped later at the end. So we're going to use the shortcut where we have 2 sine theta cosine theta. And we're going to plug in for this one. Sine theta, which is opposite over hypotenuse, we're going to use 1 over root 17. And cosine theta, which is adjacent over hypotenuse, we're going to use 4 over root 17. And this gives us 8 over 17. Now to find out what cosecant is, we flip it. So our final answer is going to be 17 over 8. So 3 pi over 8. Well, if I wanted to think of that in terms of degrees, which I like to do, I'm going to multiply by 180 over pi. And if I do all of this, I actually get 67.5 degrees, which is kind of obnoxious and not an exact value at all. But what if I think of this as 135 over 2? Now 135 shows up on the unit circle, and everything works out great. So I can use the half angle formula to figure out this exact value. So if I think about the cosine of 135 degrees, that's going to be negative root 2 over 2. And I'm going to use that and plug it into this other formula, because the sine of u over 2 is equal to plus or minus the square root of 1 minus the cosine of 135, which is negative root 2 over 2, all over 2. If I want to cancel out this, I can do times 2 and times 2. So this becomes plus or minus the square root of 2 plus root 2 over 2. Now I could rationalize it further from here probably, but I'm going to leave that for sine of u over 2. I'm going to leave it as plus or minus the square root of, almost made a mistake here. This would be a 4 when you multiply it by 2. So we'll put on the top 2 plus root 2, and on the bottom 2. And the square root covers all of that. Since the square root of 4 comes out even, we remove that part of it. To find the cosine, I'm going to plug in like this. So right there, I will plug in negative root 2 over 2. And if I simplify a little bit, here's my answer for cosine. So notice the only difference between these two is the top one has a plus and the bottom one has a minus. That's just a slightly different version of the formula. The sine formula is 1 minus cosine of u, and the cosine formula is 1 plus cosine of u. But everything else is the same. Then, tangent, we can just use sine over cos. So we should actually rewrite this as tangent, because that's what it is. And our answer is going to be plus or minus the square root of 2 plus 1. Let's see how we get there. Well, the first step is to do it like this, where the 2's cancel out. After that, if I want to deal with the square roots, I have to find a way to get rid of these radicals. So one way to do that is to multiply by this on the top and on the bottom. This is kind of like when we multiplied i's by i's to cancel them out. We're multiplying root 2's by root 2's to cancel them out. And if we do that, and by the way, we can keep this all underneath the radical and just multiply right there, we can simplify to this, where the top part is 2 plus root 2 squared. And the bottom part, using difference of squares, 2 times 2, the middle terms cancel out, and then we minus 2. So the bottom part actually becomes 4 minus 2, or just 2. And then, do you notice that we dropped the square root from the bottom? That's because we applied it there. So another way of simplifying this, let's split it so that the square and the square root cancel out. So on the top we have 2 plus root 2 all over root 2. And we can split that into 2 over root 2 plus root 2 over root 2. And if we rationalize, that's how we end up with this. Long way to get there. Last problem. Let's start here. What does that mean? That means we're in quadrant 3. So if you think about, here's pi, here's 3 pi over 2. We're at negative and negative down here in the bottom left quadrant, quadrant 3. So we can write that tangent of u is equal to 1/3 if we want. And then we can figure out that cosine of u is 3 over root 10. And we could keep going, but that's all we really need to plug into these different formulas. So we can say that sine of u over 2 is equal to plus or minus the square root of 1 minus 3 root 10. 3 over root 10, sorry. And then on the bottom, it goes to 2. So if we want to get rid of that, we can multiply by root 10 over root 10. And this becomes root 10 minus 3. When we distribute, and then on the bottom, we're going to have 2 root 10. And this is still all underneath the radical. And if I want to simplify that one more time, I can take and multiply by root 10 over 10 again. So that I eventually get here 10 minus 3 root 10 all over 20. And that is my sine. And I follow those same steps, and for cosine, I end up with 10 plus 3 root 10 all over 20, plus or minus square root of. And then for tangent, it's the ratio between the two, so it ends up being the square root of 10 minus 3 root 10, which is sine, divided by 10 plus 3 root 10, which is cosine.